Let's now write the VHDL code for a 4-bit shift register with synchronous reset and load. Here, in a 4-bit shift register, you have only one data input, that is data in, and it is a single bit. Basically, you are able to shift only one bit for every clock cycle in a 4-bit shift register. So the block diagram is going to look as follows. You're going to have shift register, clock, data in, which is 1 bit, and then you have data out, which is 4 bits, because your data out is Q3, Q2, Q1, Q0, so that's 4 bits. And then you have reset and also a load. So let's see how the system works. The one thing that you need to remember here is the output Q of flip-flop 3 is fed into the input of flip-flop 2, right? So if you try to declare Q as an output, then you cannot use it as the input for the next flip-flop. That's a VHDL error. It's not going to allow something that you declared as an output to be used as the input for the next entity or the next component. So for that, I can declare a temporary variable. So I'm going to call this as temp3, temp2, temp1, and temp0. So let's write the entity. First, the library files, library IEEE, use IEEE dot standard logic underscore 1164.all entity shift register is port. It has data in, reset, load, and clock as inputs. All are single bit. And it has data out, which is out standard logic 3 down to 0, or out standard logic vector 3 down to 0. You can also try to write a generic version, but I would just want to explain the 4-bit version, and then you can extend it later. Architecture. Arch of shift register is, I'm going to make a signal called temp, standard logic vector 3 down to 0, begin. It's a synchronous system, so process of clock. So if there is a rising edge of the clock, so if clock tick event and clock equals to 1, then that is when you check reset. If reset equals to 0, then I'm going to say temp equals others gets 0. So basically it is going to set temp as 0, 0, 0, 0, or it is also going to say this point as 0, this point as 0, this point as 0, and this point as 0. Else if load equals to 1, then I'm going to say temp equals the new data that is coming in, data in, and temp 3 down to 1. End if, end if, end process. So there are a few things that are happening here. So if load equals to 1, then you're shifting in the new data, right? So if you had this as your previous state, temp, so that's 3210, and you are loading a value 1, so let's say data in equals to 1, then the next state of your temp is the 1 is shifted in, so 3210, the 1 is shifted in, and these three have to go here. The AND is also known as the concatenation operator. So you're concatenating data in with these three. So that becomes this one here. Now we have set temp as zeros initially, right? But what about queues? Our main output is the queue, it's not temp. So queue is always equals to temp. And I can write data out is always equals to temp. So that's it. That's the code for a 4-bit shift register. Now I wrote data out equals to temp outside of process because this block is only going to get executed if there is a rising edge of the clock or if there is a change in the clock. And your output is always equals to temp no matter what, which is why this just goes outside of the process block. I can end my architecture here.